Hi, this is Matt Vardabedian. I'm the moderator for the webinar. We'll kick it off here in a minute. But this is obviously the Agriculture Enterprise 5G Private Network webinar. Okay, we'll start up. Welcome. Thank you for attending this webinar on the opportunity for private networks in the agriculture sector. My name is Matt Vardabedian. I'm with IGR, and I'll be the moderator for this webinar. As a reminder, we are recording this session, and the recording of this webinar will be available after the event. If you have any questions, please ask them as we go along. It's totally fine. And I believe there's a questions tab in the lower right-hand side of your GoToWebinar interface. Just use that, and then I'll see them and raise them to our presenters as we go along. I would like to thank the OnGo Alliance for their support with this webinar series, and I'd also like to thank the Yield Lab Institute for their support as well. Our presenters today are Mark with Nokia and Ozer with Celona. Mark Brandt leads the business development efforts for private wireless within Nokia Enterprise for the North American market, with a focus on the agriculture, transportation, and logistics sectors. Mark is responsible for the identification of new business opportunities, application of Nokia's vast technology portfolio, and evangelizing the advent of private LTE and 5G technology. Ozer leads marketing activities at Celona, along with managing channel and ecosystem partnerships. Prior to Celona, he has led a variety of go-to-market activities during his 10+ years at Aruba. Just to review the agenda real quick, Nokia will be speaking first, followed by Celona, and everybody is going to be talking about how big the agricultural opportunity is in the US and globally to a certain extent. And everybody's going to be talking about what you see here, the use cases for 5G, private networks, etc., the main communications needs for the sector, as well as some of the critical success factors for private networks using LTE or new radio in the CBRS band or other sub-6 gigahertz bands. And this is all particular to the agriculture sector, of course. And then I'll provide a quick summary and we'll get to your questions. So this slide, is incredibly busy as it is our overview of enterprise connectivity and applications across multiple industry sectors, everything from transportation to manufacturing to commercial real estate. You can see agriculture up there in the top left-hand corner. And there's multiple applications and solutions that are applicable in that particular sector. With respect to private networks, building one can be pretty daunting, particularly since the wireless industry is good at acronyms and confusing terms, which can be challenging to the most seasoned of IT executives and even analysts. At sometimes there's always a new acronym right around the corner. To date, many companies across a variety of verticals have deployed private networks, mostly using LTE today, but as the CBRS band is available, and we expect rollouts of solutions in that band to continue moving forward. And we expect new radio to be one of the solutions, private network solutions deployed in that band as well, moving forward. With respect to agriculture in particular, there's a wide range of applications and use cases, as I mentioned. IoT is a big one. Sensors have already been developed in that sector that track everything on a crops basis, from temperature, precipitation, light, humidity, and with respect to livestock, everything from location tracking to health of the animals to their behavior, etc. There's also another grouping of solutions called precision agriculture or precision farming. And this includes applications like robots that are being used for weeding, spraying pesticides, picking crops, milking cows, handling materials, as well as drones that can be used to spray pesticides, and even their cameras can be used to monitor the growth of fields. And as I said, the panelists will discuss other use cases as well. All of these solutions require some type of network connectivity, compute power, and obviously some way to display the relevant and important information to farmers. On this slide, we see that there are just over 2 million farms in the US at the end of 2019, according to the USDA. We anticipate, if you look at the left-hand graph, the number of large farms to increase, while the number of medium farms to decrease through 2024 and likely beyond. We also expect the total acreage to decrease very slightly. If you note the scale, it's not a huge drop, but it is a slight decline. And this is largely due to efficiency gains and the turning over of farmland to housing or sites for warehouses, et cetera. So with that, I would like to hand it over to Mark Brandt to pick up his section of the presentation. Thanks,
Well, thanks, Matt. Thank you for the introduction and for allowing us the opportunity to share Nokia's vision for how agricultural operations can benefit from reliable wireless connectivity. You mentioned the total number of farms at about 2 million, and the trend for decades has been fewer numbers of farms that are larger in size. So we've also seen the real estate investment trusts come into the market, and they're purchasing large tracts of agricultural property and developing it, improving the infrastructure, investing in technology, and yielding some of the benefits from this. And clearly, if they're doing it and they're getting a positive return on their investment, we should be paying a little closer attention. So from row crop operations to livestock to orchards, vineyards, entrepreneurs are investing in the technology needed to gain efficiencies, reduce their cost, and increase their yields. So what's needed to adopt these digital techniques, this digital transformation journey, is reliable connectivity. So if we look across the US now, roughly just under half of US farmland has some form of cellular coverage on it. Now, that particular coverage is not necessarily good coverage. A lot of times it's the fringe coverage or cell edge where reliability and performance are questionable. So clearly something needs to be done to address wireless coverage across the farmland in the US. And this is where Nokia believes that it can add value. Next slide, please. So Nokia, you may have heard of it, you may be familiar with this, you may not. You may remember us for the cool little candy bar phones that we made in the 90s. But we're a $26+ billion top line corporation that sells infrastructure and telecommunications infrastructure to the world's carriers. Of that 26 billion, about 2 billion is derived from sales to the enterprise. So in 2019, Nokia stood up a separate enterprise division to put a laser focus on growing this segment of our business. And so this is where we start to connect the dots between Nokia and agriculture. So one of the main products created for the enterprise group to sell was the concept of private wireless. These networks became available once the FCC released the CBRS spectrum, which they did in January of 2020. CBRS spectrum became available for commercial use in the US. So the private LTE and 5G networks that use this spectrum were designed to meet the needs of the industrial users. and industrial sectors, of which agriculture is just one such example. You know, farms are just factories without a roof. So we consider agriculture to be an industrial sector. And we've taken that same product, the infrastructure, the software, and the services that we provide for the world's carriers, and we have scaled them down, shrunk them, if you will, to be able to fit in the enterprise space and be a cost-effective solution for enterprises. So what do we mean when we talk about a private wireless network? Well, a private wireless network is one in which the operator controls who goes on the network. So if you're a farming operation, only your devices and your users will attach to this network. So it's not like the public driving by the highway is going to roam over onto this network. Furthermore, you control the coverage. You put the coverage, so you're providing a bubble of coverage for your property. You're not trying to cover anything else, just focused on your own operations. So with a private network, if you control the 3 C's, that is coverage, capacity, and you operate it in clean channels, then you can get predictable results for performance. As a matter of fact, it's a mathematical certainty that a private LTE network that's been tested in the labs and verified out in the field, that you can get 99.999% network availability. In addition, when you're designing this, the capacity of this network to fit your user profile, then you can operate it with a relatively stable latency figure. And with the private LTE networks and 5G networks, that's under 20 milliseconds. So these private LTE and 5G networks are well positioned to be able to provide connectivity, reliable connectivity in the industrial sector. And these reliability numbers are things that Wi-Fi can't touch and public cellular cannot achieve. These can only be achieved with the use of private networks where you're controlling the 3 C's. So next slide, please. Let's take a look at some of these use cases. So here we're going to take a simplified approach in looking at a row crop operation. And so here you see the blue is the Nokia network, if you will. So we start out with a small cell that we put on top of a radio tower. Maybe that's an 80 to 100 foot tower. It has a small cell on top of it, and that small cell is connected. Maybe it's placed next to the barn, and you've got a local edge server in an office or inside the barn area there that controls that small cell. Now that local edge server performs some of the core functions that are needed to operate the LTE or 5G network, but also it's able to host applications. So Nokia has a large catalog of applications that can be loaded down to this, but also third-party applications can reside on this platform too. So it brings a digital transformation platform to the farm so that you can run your apps from that server. They're managed by the third component here, and that is the Nokia Digital Automation Cloud. And this cloud is where all the magic happens. So the cloud manages the local edge server and the base stations, and it sends the configuration information down to them. It also has a customer portal so that you can connect to it and have a dashboard view of what your local network's doing, what your local devices are doing. And the beauty of this, by combining some of the elements of the core in this cloud and putting the ones that are essential for local communications down on the local edge server, you take the complexity out of these LTE and 5G networks. So we like to say this is truly plug and play. If you were to purchase this system and put it on your property, you would configure it in the cloud before you even unbox the equipment locally. And then you would just go merely install the small cell on the tower, run a cable to the edge server, connect the edge server to the internet, and then just plug it into the wall. And it's going to reach out, that edge server is going to reach out, contact the cloud, pull its configuration down, and bring your network up. And for most industrial operations, that's all they ever need to do. You don't ever need to go back and touch the network. So we like to say that if you can deploy a Wi-Fi network, or you can deploy a 900 meg radio system, or a mobile radio system, then you can deploy one of these. You don't have to have an advanced degree in LTE or 5G technology to do it. It's pretty straightforward, pretty simple. And we bring that same carrier grade reliability down into this product line as well. So let's take a look at some of these use cases that we have in front of us here. So maybe you have tanks on the property and you need to know what the level is. Of course, you can put a level sensor in there, have it connect over the wireless network and back to an application, say running on that local edge, and give you alerts when your tank levels need to be refilled. Maybe you've been having some problem on the property somewhere and you need to stand a remote security camera up. You know, that's always been prohibited from being able to get a network connection to them, but with this, you can run them over the wireless system and connect these up wherever you need to. You know, maybe you've been having trouble with people coming in and hunting out of your deer stand, and you need to keep an eye on that. So, you know, certainly there's some versatility with how you can deploy these cameras. Other things such as bin storage monitoring, maybe your bin storage system is automated and you would use a mobile tablet to be able to look into the bin system and see what's going on with that. And then let's take a look at some of the things that assist in being able to increase efficiencies and yield results on the farm. So things that hit the ROI. So a soil probe system. You mentioned probes and sensors that monitor all kinds of things about the soil and the crop condition. So those being able to connect over the private wireless system and hitting an application that then turns around and provides information about the results, that's very beneficial. So being able to monitor the soil condition for like acidity or the need for phosphate or nitrogen. So by deploying these probes, instead of just going and doing a blanket application of material uniformly across all of your farmland, you're now able to, through these digital techniques, prescribe a precise prescription for a particular section of the field. And so by doing that, now you're not blanket covering the field with nitrogen, lime, potassium, fungicides or herbicides, but you're only applying what is needed in the amount that's needed for the specific spot that needs it. And so since material costs make up the bulk of the operating costs for farmland, and this is significant savings. And let's say, for instance, you know, in addition to monitoring all the soil conditions as well as the moisture content in the soil, that you've made the decision to automate your irrigation system. So now, instead of going out and turning the irrigation system on, letting it run for however many hours you think it needs to run, and then going back and turning it off, now the digital signals or sensors are telling you, turn the irrigation system, and it's automatically doing this, automatically turn the irrigation system on and let it run until the sensors detect that it's had enough moisture and then turn it off. So now you're saving the water. You're not depleting your water table, so you're making the most efficient use of your water resource. You're also only running those pumps for the exact amount of time that they need to run, so you're managing your electricity cost, and your labor is reduced because you're not having to make 2 trips out there each day to turn them on and off. So those are examples of how the soil probes can be integrated in with some of the other systems. But the real workhorse out on the farm is the tractor. And these days, these tractors have become technological wonders. And so they're equipped typically with precision guidance systems so that they can be driven autonomously. And they do that by having a rooftop cab mounted electronics enclosure that'll have, in addition to like an LTE modem, it'll have a GPS service attached to it that uses RTK techniques for precision positioning. And this gives the ability to be able to play the tractor to know its position within inches. So if you're running these, RTK takes both the component of information that it gets from the GPS receiver on the tractor, but it also compares that to a known reference point RTK signal source that is then sent to the tractor over this wireless network, and the tractor takes that error correction and removes most all the errors out of the GPS so that you can get positioning within a couple of inches. Now these tractors, in addition to the tractor itself, but the implements that are attached to it are all taking advantage of this. So let's go to the next slide. And well, before we do, the little lower right-hand corner, another important feature is the ability for remote tractor support. With all this technology in the tractor, if you don't have a PhD in computer systems, or you don't have your 7-year-old around to help you, then you need this type of real-time support, and that's available through this connectivity model as well. So let's go to the next slide, take a little deeper look into the tractor use cases. So here we see some harvest operations, and with these techniques deployed, these tractors are being precision driven autonomously, and they're being synchronized in unison so that they can come into the field and make the most efficient use of time and movement to get the crop out of the field. So instead of taking days to get your crop out, now we're talking hours to get your crop out. So that takes a lot of the risk out from some of the variables such as weather and other things that can impact that. So you're using less time, less fuel for the tractors, and you're getting the crop out quicker. So that's a real good use case that's using that, leveraging the connectivity to each of these tractors. You need reliable connectivity in order to accomplish this, but it's quite possible. Let's go to the next slide, please. So here's another use case where we're looking at monitoring the machine in real time from that remote support expert. And as you can see, with all the panels and the displays in the tractor and the implements and what they're doing, so in order to be able to apply all these precision techniques, the tractor is doing a lot of those tasks for us. And so there's a lot of technology involved in that. And so support becomes critical. So they're able to, if you have a problem with the tractor and a light comes on and you're not able to proceed with your operations, then having that remote support, being able to connect in to quickly diagnose the problem and resolve it is critical for time management and being able to get you back on task. So that's another component here, a benefit that comes, as well as being able to monitor the machine's maintenance schedule and other things like that. So another real good tractor use case. Let's take a look at the next slide, please. So here we're going to talk a little bit about these precision prescriptions that you're able to write for your crop to improve the crop health and the soil condition and moisture and all that. So if you can control how much material you put where in the field and the moisture, manage the moisture settings, and then being able to analyze the crops for pesticide and fungicide applications, then you can minimize the amount of materials that you're using. And by micromanaging all those parameters, then you're going to have tall, healthy plants that have big yields associated with them. So not only employing sustainable use techniques for the limited resources that you have, but also you're reducing labor costs, you're reducing materials costs, and you're increasing productivity as well as yield, which then is increased revenue. So all of these things add up, and by the more of these little digital techniques you employ, then the greater the savings opportunities present themselves. Next slide, please. So here we look at this value proposition and the value that, defines your willingness to be able to invest in this technology. So by reducing the cost for all your inputs, and all the different materials you're using, the time, the electricity, you adding all these things up, and you're reducing those costs, then you're, as well as enjoying the benefits from increased yields because of the plant health, then you're creating this economic headroom for investment. So you're also getting better decision making from all your data and insights that's being fed. It's said that farmers have to make thousands of decisions over the life cycle of a crop and over a season in the crop. And those decisions have to be made quickly. So you need good information to make good decisions. So you're going to protect your assets, reduce your material costs, decrease a lot of your risk. And all this are just examples of the value that's brought about when you make this investment in technology. But of course, all this is just paper talk until you have some kind of way to be able to calculate these ROI potentials. So let's go to the next slide. So most agricultural extension offices, like the county ag office or the state universities, all in their agricultural department, they all put out these little budget analyzer spreadsheets, and it's specific for the region, and it also is unique for each of the different types of crops. And over on the one side, you have all your cost inputs, how much starter fertilizer, how much phosphate to put down, how much nitrogen, and how much of that you're going to put down, what it costs, how much you apply per acre, and what's your total acreage, as well as maintenance on all your equipment, electricity, labor. And so you have all your cost columns. And then they provide on the other side, on the revenue side, here, if your yield is this, and here's the number of acres, and here's your cost structure. So here's what your return per acre is going to look like. And so if you can then take the numbers knowing that you're going to put down maybe 15% less nitrogen, 10% less lime, less of fungicide, less herbicide, and you can plug those into your cost structure, then you'll see that return per acre go up. And then if your yield's going up, then your calculator here can tell you this. So all of these things come together to create a picture for the farmer so that he can have confidence that by making these investments in this technology, that he's able to get a return on that investment. And this gives him a tangible method for being able to calculate that in advance and know what he's getting into. So just want to thank you for allowing us the opportunity to present our value proposition. And we believe that all of this technology starts with a foundation based on a reliable wireless connection. So thank you very much.
Awesome. Thanks, Mark. Ozer, if you're ready to get going, we'll just jump right into your section of the presentation. And here you go.
Absolutely. Thanks, Mark, for that great intro. Lots of great use cases. Awesome to be partnering up with you and Matt/Ian. Thanks for hosting us, and everybody on the line. Thanks for listening. In case we need to follow up afterwards, in case you have any questions, you can find us at hello@Salona.io as I go through the presentation, or of course, feel free to submit your questions on the chat box right there. So who is Salona? I am the VP of Marketing at Salona. I've been with the company for the last 18 months. And the team is 2 years old. Initial investments came from NTT Venture Capital, Norwest Venture Partners, sorry, Lightspeed and Servin, tier 1 VCs here in the Bay Area. And then NTT VC and Qualcomm Ventures became our strategic investors in the last round. And they really, come from lots of experience in the enterprise IT networking space. And the team, Rajiv, Mehmet, and Suparna, their backgrounds, I think, was a great match for the opportunity that our investors saw in the private 5G space. It's a mix of experiences from enterprise networking, cloud services, and IoT infrastructure for service providers with engineering backgrounds from Aruba, Qualcomm, and Jasper. So we kind of consider ourselves to be the cloud networking solution for private 5G. What does that mean? That means make it easier to deploy, remotely managed, easy to scale across many sites, indoors and outdoors. And that unique technology approach, that laser focus on enterprise environments, has won us a couple of awards. We hope to see them coming, but for a young team like us, we really are excited about the attention we're getting from our customers, channel partners, and from you all. So in the next slide, I'm gonna start unwrapping the onion a little bit. Ultimately, what are we trying to do at Celona? We're trying to get our, private 5G solution easily deployable. So it's an integrated package. I'm going to tell you a little bit more about it with a network diagram, how it all fits within your existing networking stack. We presented as a one-kit solution because we realized that there's a gap in the market where you can work with multiple technology providers to set up a private 5G network, but we said that might be just too costly and too time-consuming for enterprise IT or OT teams. The second piece of the puzzle, 5G promises a lot of different benefits. Today, our access points are LTE access points, but we bring in some of the 5G features in advance of our 5G radios. We have a unique technology called microslicing. It's the first adoption of 5G network slicing in an enterprise environment, and I'm going to tell you a little bit more about it, about its value, about its unique capabilities as it might relate to your environment. We deploy within your existing environment. So this is think of it as any other enterprise networking solution, plug and play, works with the existing systems that you already have in place in the IT infrastructure. And you should be up and running with a trial in an afternoon and a deployment in a couple of days. So, and the cost basis is very similar to a Wi-Fi cost basis, indoors and outdoors. So if you have that frame of mind, spending X amount of dollars for Wi-Fi per square footage, you're probably going to be one-to-one in this regard. And that has been a pretty unique differentiator for us out there in the market, improving the consumability of the technology. Since we're buying this as a product, as a technology, just like you would buy any other enterprise networking gear, we don't have this concept of non-metered cost, metered cost per device. So the consumption model is non-metered. It doesn't matter how many devices you connect, how many SIM cards we provide you for LTE connectivity. It's just, you just simply acquire the infrastructure and the devices can scale independent of the cost of the solution. So that's kind of the executive summary, but let's dive in a little bit deeper in the next slide. So where do we fit? Many of you have interacted probably with networking technologies within your facilities. You, of course, relied on Ethernet technologies, and primarily we kind of looked at Ethernet as personal compute, static locations, and we continue to take advantage of that. And then Wi-Fi came along, changed a bunch of things, opened the doors for many new applications that we never thought of would be possible to run within an enterprise. Now we actually do, thanks to Wi-Fi. And LTE 5G, we see a similar pattern emerging. We see a lot of robotics, data collection, real-time applications like voice and video being very applicable to the predictability that LTE 5G offers. So we call these apps real-time compute. Usually the things that should not go down, the things that you spend quite a bit of chunk of dollars probably acquiring and implementing as part of a digital initiative. Stuff that needs low latency and really wide area coverage, especially in agriculture, of course, as Mark referred to. LTE 5G sits there, right? So we're not necessarily advocating for replacing existing technologies, but this is opening doors to many new apps, many new use cases that we never thought was, again, possible. So in the next slide, a little bit more perhaps examples of what your strategy could be depending on which part of your organization you are in, or as a perhaps a channel partner, how you're supporting your customers, right? I believe that we have a mix of audiences on the webinar, both end customers in the enterprise and channel partners to support them. So I thought that this could be a good kind of 1, 2, 3 on how to guide these conversations. IT teams that we talk to, they usually care about, is my network up and running, right? They care about service levels, they care about uptime. And they do spend a lot of time on best practices and design, configuration, latest, greatest technology to make sure that that uptime is satisfied. So the next audience, usually operational technology that likes to partner with the IT team who builds the networks, but their priority is, how do I optimize my initiatives? How do I spend 2 hours instead of 2 days trying to get the data out of my facilities? Can I spend a few hours in enabling my staff to do something instead of spending days, right? So their networking needs usually a secondary thought, right? We usually like to say OT teams like to cause some trouble for the IT networking professionals because they're laser focused on building the next application that impacts the business outcomes that Mark was also referring to. And then there's usually innovation team, and innovation teams, they don't necessarily have strict timelines, but they like to investigate what private 5G is, where should it sit within the technology stack, within the environment, and they're usually the ones that actually do POC or pilots for the solution. I mean, private LTE 5G solutions, especially the ones that we provide, which is laser focused on the CBRS spectrum, unlicensed, cost-free CBRS spectrum, that is relatively new. It's only about a year old. As I mentioned, we're also 2 years old. So this new initiative, this new technology usually goes after the innovation teams in the initial engagements for POCs and pilots. And that's where you really kind of discover some of the new use cases that sometimes we never even thought about. All right, in the next slide, I provide a couple of additional details. Perhaps, Mark also gave you a pretty wide picture on the use cases here, but 3 things that we have been able to talk to our customers about, run pilots with, actually supported in the real world. So one of them is, of course, capturing environmental data. You might have systems, IoT infrastructure that's already in place, but then you're looking for a backhaul solution. Hey, I have the IoT sensors. I need to get a gateway in between my IoT sensors and my backbone infrastructure. Those gateways today, there are a wide variety of device options for that solution. You can go to Celona.io/devices to see a full list. And those gateways kind of act as the backhaul for perhaps an outdoor CBRS LTE deployment. In addition, once you have this network in place, you can start taking action after that data collection, right? Hey, I'm collecting data, I'm computing some algorithms to give me some results, take action, to change things, to optimize work processes, etc. And then once you're doing that, of course, once you have this wide area coverage, hey, let's use a Samsung smartphone, a Zebra, iPad, tablet, and also do our jobs while we're in the field, right? This wide area coverage also gives you the benefit of using easily accessible mobile devices to connect to this network. And since we're dealing with a highly encrypted, highly secure network, and thanks to CBRS, since we're dealing with an interference-free network, that digital operation, whether it's voice communications or just simple data entry, is delivered a highly predictable performance. All right, in the next slide, I believe I have an example. In fact, CBRS Alliance, now the OnGo Alliance, has awarded this specific deployment recently, just because of the cutting edge approach that Rural Cloud Initiative has taken. And the idea here was to simply cover areas where Wi-Fi will not be able to provide large coverage areas. A single outdoor Wi-Fi access point, you might already know, covers about 100,000 square feet or so. We can extend that with a CBRS-based private LTE to 1 million square feet of coverage, perhaps even larger ranges if you use directional antennas. So instead of rolling out tons of cabling, lots of outdoor Wi-Fi mesh systems, more cost effectively actually, we were able to cover for CBRS gateways from a company called Multitech, which translated IoT sensor data to CBRS backhaul in this large coverage area for the initiative. So the deployment is still going on. There's lots of automation being thought about. Our infrastructure also can be accessed through APIs. So since we are a cloud-first solution, the team there is actually interested in collecting real-time information through our APIs and improving their view, remote management capabilities for this entire installation. So it's been a very exciting to be part of this initiative. And the next slide, a little bit more color, probably what we provide in the next few slides, I would say. So I told you about the solution being a package solution. As Mark also mentioned, our approach is similar in that we provide a system that can be deployed, managed from the cloud, indoor, outdoor. Each access point comes with a certain number of SIM cards. So we also take care of the SIM provisioning. For CBRS spectrum access, there's a process that needs to be done with FCC. It's generally called a spectrum access service system registration. And we take care of that complexity. So as an end customer, actually, you don't necessarily have to worry about that. So once you deploy the solution, the spectrum is available and you can connect your devices. It's that simple, just like you do with Wi-Fi today. In the next slide, I want to unwrap this a little bit more. The unique microslicing technology that I mentioned earlier on does a couple of things very interestingly for enterprise networking professionals, especially. Some of this would be obvious, but if you're coming from the cellular wireless world, this is going to sound probably quite innovative. The first thing that microslicing does is, as our infrastructure gets built on top of an existing environment, we actually start learning from the enterprise policy and network configuration. So I have IP subnets, VLANs, access policies for different device groups, user groups already defined as an enterprise. I already do that for Ethernet and Wi-Fi. So we take advantage of that. We learn that configuration so that we can map that to video, voice, tablet, variety of different traffic types, different device groups as microslices. This has not been possible prior simply because every LTE 5G solution assumed that, hey, we're actually connecting to a mobile operator network. This tight integration has not been possible so far. The second thing that microslicing does is, of course, as devices roam around, as we add more access points for more coverage, we need to continue our focus on application reliability. As I mentioned, we build these networks for highly critical apps that has to work, those applications that require real-time compute. So each one of these slices can actually promise a specific throughput, latency jitter, and packet error rate to individual streams. As devices roam around, as we add more access points, we make sure that our cloud-based system called Salon Orchestrator generates those insights, enables that KPI level monitoring, and if we need to take action to improve the latency metric, for example, for an application, we do that in real time. So that's microslicing. It has been our secret sauce, if you will, in our ability to very quickly deploy private LTE systems in any enterprise IT environment. So in the next slide, I'm going to actually show you how this can be integrated. So this can be your network today. You got your WAN services. Maybe you have some apps running on the cloud. Your Wi-Fi management is running there. On-prem, You might have some edge compute applications. You might be using Azure, AWS Edge Compute, or maybe you're just relying on bare metal servers or virtual machines, whatever it might be. That app infrastructure generally also has some network services like a Wi-Fi controller. And then you have Wi-Fi APs connecting to your Wi-Fi capable devices. And with one more click, Matt, if you don't mind, you can see our solution kind of fit right into what you already have. So your existing edge compute infrastructure, your existing server stack on premises will run our network services platform called Salona Edge. It's a cloud native platform. It can be deployed as a virtual machine, as a bare metal, on your Azure, AWS Edge Compute platforms, whatever it might be, and then integrates with the network services that I mentioned in the previous slide. Same LAN infrastructure, same IP subnets, same cabling, same PoE plus switches. They support Salona access points for CBRS LTE connectivity, dedicated set of devices running Salona SIM, and then we integrate with the infrastructure. Cloud management comes with Salona Orchestrate, as I mentioned, and we take care of the SAS registration, Spectrum Access System registration for CBRS Spectrum Access for you. As an end customer, you don't have to worry about that complexity. All right, so I think I'm getting pretty close to the end, I believe. In the I believe that's it, as I predicted. So as I mentioned, you can find us at hello@salona.io. Check out our website too. If you want to see this technology in action, we host a bi-weekly webinar. The next one is actually coming up next Tuesday. A live demo, 30 minutes, 10 minutes of introduction to Salona, 20 minutes of Q&A and live demo, where we showcase our technology from configuration, setup to device connectivity to microslicing. And if you're curious about those devices, what kind of devices I can connect to my network, again, that URL is salona.io/devices. So with that, I will hand it back over to you, Matt. Thanks again for having me. Thanks for listening.
Thanks, Ozer. Yeah, now would be a great time to start asking some questions. I've got some that have come through already, but I'm going to jump into a quick summary, and then we'll go into the kind of the question and answer phase in the last few minutes of the webinar. So just to sum things up, as has been, I think, demonstrated, agriculture is a, no pun intended, growing opportunity. The adoption of IoT can help make farming much more efficient and productive. And there's a need for scalable solutions, both from the network side as well as from the kind of the device side of things and the application side of things. They can cover not only large areas, but also support many different use cases. And as we've seen, there's tons of different use cases. On that one slide, I think Mark had 15 or 20 different use cases alone that doesn't even really touch on some of the other stuff that could be implemented. And the demand for connectivity is real. As was mentioned, there's plenty of options from Wi-Fi to Bluetooth that is already deployed in some cases in some of these sensor systems, but there's also a wider range of alternatives like LoRa or Sigfox or even LTE and New Radio and the other sub-6 gigahertz bands that are primarily licensed by the mobile network operators. And there's pros and cons to all of them. One of the reasons why we think CBRS is going to play a major role here in the US is that a network operator, mobile operator, is not required. The system can be deployed very similarly to how Wi-Fi can be deployed. A farm or an enterprise or what have you could legitimately just get it up and running on their own. The band in and of itself has really good throughput and propagation. And one of the main challenges with outdoor small cells in non-farm environments is the lack of, or the difficulty in finding sites for all those small cells. On a farm, the farm owns all of it, so they've got carte blanche on where to deploy all the different antennas and radios and systems and all that kind of stuff that make up the solution. And as we've seen, these agricultural solutions are pretty complex, and the farmers are perhaps more occupied with farming and running their business than they are with managing the apps and the networks and the data centers and all the different connectivity options. So in our opinion, that's a great opportunity for a third party to step up or step in. So with that, start answering some questions that have come through, and just wanted to remind you that the webinar is being recorded and that recording will become available, if not today, then probably tomorrow or the next day, and some websites to look at for some more information. And into questions and answers. So the first one that has come through, I was jotting it down, from Mark. What, any thoughts on the role of mobile network operators or farm equipment providers in getting private networks deployed onto farms?
Absolutely. So service provider as a service is, encouraged. So any operators that are wanting to come in and deploy private networks, that's certainly an opportunity for them, and we'd be glad to work with them on that. We have distributorships and channel partners who are actively engaged as well. So these are, multiple paths to market here that Nokia is willing to pursue them all.
Do you guys go direct to the market, or is it primarily through channel partners?
Both, mixture of both, primarily, through force multiplication through channel partner arrangements. But, if it's customer, that's the customer's preference. If the customer wants to go direct, we'll talk to them that way. If they want to go through channel partners, that works fine for us. We're just there to make sure that they get the right products and services they need to be successful in what they're trying to accomplish. Gotcha.
Was there one question that came in, I think is best for you, obviously, because it was relating to your overlay. How do you say the Celonis solution overlays what's already there? What's your sense of how that looks in real life? Do farms already have networks in operation that are being used for farm or even personal purposes?
Yeah, you bet. It's usually, of course, some of these locations might have a small IT closet, if that. And generally, the IT data center in the traditional sense might be off campus. So the location could be supported with a wide area networking router, something like from Cisco or Juniper. And that broadband connectivity can actually support our system pretty reliably. And just like you use it for just data connectivity to that site, broadband connectivity to that site, you can deploy our platform in an external data center supporting many of these farm sites. And those sites, with each of them having one or two access points, they can actually come back to this centralized location. That traffic can be encrypted at that location and then distributed to the rest of the backbone network. Now, some traffic might also be destined for just pure cloud. Some of them could be rerouted to the private environment. And if you have, a kind of a design in mind for coverage and application flow, it's relatively easy to change this over time too. So you might have two sites that just have APs. You might have one large site, maybe you actually have edge compute applications running on-prem, and you want to manage it all from a single dashboard. That's completely possible. These things can be moved and changed, just like you're able to take a switch, move it to another part of the network, another branch site, and reconfigure it as you need it. It's the same idea here. That cloud networking principles also apply. And so it really depends on how much compute resources do you need on site for real-time response. If you have an application that runs and requires 75 milliseconds of latency, it's probably a good idea to run it on-prem. But if you don't have stringent requirements on throughput latency on the wide area network, then perhaps you can push some of those apps to a centralized data center where our services can also run. So relatively flexible.
Gotcha. Mark, in your presentation, in one of the early slides, you showed a internet connection back to, I guess, a Nokia Cloud Center or something like that. can you provide a little bit more detail on what that looks like? And
Well, sure.
what kind of internet connection is actually required?
Okay, so all this connectivity is predicated upon having some sort of a connection to the internet. If you're using CBRS channels, you need access to the spectrum allocation service, so that does require an internet connection. As far as the Nokia Digital Cloud is concerned, that connection is needed for the initial config of the network, to push the configs out and to push the user database out. But once those factors are in place, then the connection to the region, to the digital cloud is not a requirement for communications. The data does stay local. It does not leave the premise and loop through the cloud and come back. So much like wireless LAN architecture, that data stays local. But internet connectivity is becoming more and more of a need in these rural locations. Thus, this whole rural connectivity initiative that's taking place to try to light all of the farmland up with internet connectivity. And there's lots of federal funds that are available right now to assist people in accomplishing that. Because if you think about it, your remote tractor support, that's going to be predicated upon a connection to the internet in order to get out. So certainly you can build your own network on site and provide some small satellite modem or to be able to get that connectivity out and then minimize the amount of traffic that goes over it. So there's options that are available out there as you architect a solution for these systems.
Cool. One more question probably for both of you guys, maybe slightly different takes on it. Given the initial investment cost of these solutions in general, do you have an average idea of the estimated payback period for the farm or the operation? I don't know who might want to take a stab at it first.
I can jump in, Matt. There's usually values defined in number of hours saved and amount of uptime for individual applications on average. So for example, I don't remember the numbers on top of my head for agriculture, but the impact, time savings, impact of precision data collection, uptime of the wireless network versus how much that impacts your ongoing staff operations. So there's some industry standard numbers. It's relatively easy for us to say, look, more coverage, more reliable performance, interference-free wireless operation. Your mobile devices don't go down as much. You cover a lot more areas for a lot more data collection. You can connect a lot more devices. That translates to uptime pretty clearly. And from there, for any environment, we can probably create a custom ROI metric, which we have done for a variety of different customers as they look at bigger installations. So certainly doable. It just requires some conversation with the what the deployment looks like and what type of use cases we're supporting.
Gotcha. Mark, any thoughts?
Yeah, I'd go back to the spreadsheet budget analyzer, and for the particular type of operation that will tell what all those input costs are and what the revenue potential is, and then you look at what your goals for savings are across the opportunities such as reduced material costs, labor costs, and all the other cost factors that would come along with the investment in the digital technology. Then that gives you an idea of what that return would look like and what the time period. If we're just talking for the connectivity portion of the solution, like Ozer mentioned earlier, it's the same for us. It's cost competitive with Wi-Fi, and for large outdoor operations, it's actually quite a bit lower total cost of ownership than Wi-Fi, significantly lower cost. But in any event, we'd be willing to sit down and work with customers to help them to better understand those opportunities and to prepare a business case for how they can justify the expenditures.
Great, thank you. Well, we're just about at the hour, so I think that's probably a good note to close things up on. Mark, Ozer, thanks so much for your time today and fantastic information that you provided. And thanks everyone for attending. Again, the webinar will become available after we're finished here. And thanks again for everybody's time. Have a great day.
All right, thank you, everybody.
Thanks, everybody.
All right, and that's a wrap.